Hello students. In today's lecture we are going to start our fourth e-learning class in the 10th standard science. That will be the chapter number 2, acid, base and salt. Before going to start our next topic in today's lecture, we are going to see in today's lecture the Chlor-Alkali method that gives us the 3 byproducts, and that will be used in the washing soda, baking soda, and will be used in the bleaching powder. So we are going to see how to make the washing soda, baking soda and bleaching powder. Also we are going to see the uses of baking soda, washing soda and bleaching powder, and also we are going to see the disadvantages of that. But these are the byproducts of Chlor-Alkali method. So going on going on a common salt, we are going to see what we have learned in till today's lecture. Okay, so we are going to take a brief preview on the previous lectures. That will be what we have learned so far. We have learned the parts regarding the acid, base, chemical properties of acid. What is the acid? Generally, the sour taste substance has contained the acid. The bitter taste substance will be contained the base. That we have seen the chemical properties of acid, and which we have seen how the acid will react with the other substances. And other substances we have take the metals, metal oxide, we have take the base, we have take the metal carbonate, and all together they have do some kind of reaction with each other. Afterwards we have seen the base chemical properties, in which we have seen how the base will react with the acid, how the base will react with non-metallic oxide, what is happened with the base if we react them with the non-metallic oxide. Also we have seen what happened when an acid and base get together. It makes the two product, that will be the salt and the water. The reaction which can be called as the neutralization reaction. Also the type of reaction that will take the neutralization process will be called as the double displacement reaction, in which afterwards we have seen the pH scale. So we have seen the common component or common ion between the acid and base, that will be the hydrogen ion. So we have learned that if I measure the power of hydrogen, and that can give the substance value of some kind of value, and that can particularly I have to reference it with the sum of the other values, then I have get the value regarding the substance what that contains the power. Okay, and this defines us that it is an acid or it is in a base. Afterwards we have seen pH scale gives the value regarding 0 to 7 will be considered as the acid, 7 will be the neutral, and 7 to 14 will be the base value. We have seen the importance of pH in our daily life, that in which we have seen the two topics regarding that in digestive system and also in a tooth decay, and also the importance in our daily life. In daily life we have seen that whenever the acid rain comes onto the water or lake or river, then it will contaminated the liquid or the river, lake or the river, and also it contaminated the living thing that that is present on the lake and the river. Also aquatic animals and aquatic plants gets destroyed, okay, from that acid rain comes into that. So what was the reason for that? That generally the reason is for that acidic rain contains the acidic power, and it goes down to the lake, and it will increase the level of amount of acid that will present in the water. It will increase the level of acid in that, and generally our living organisms or our living beings cannot survive minor changes of acidic. Okay, so for that purpose we have seen that we have to learn the pH, okay, power of hydrogen's value we have to learn. Otherwise we how do we know that what type of changes occurred in the lake or the river? Okay. Also we have seen that the tooth decay is happened due to the pH goes down. We have seen the salts. Now we are going to see about the salts, in which we have seen the common salt. Generally the common salt will known as NaCl. This is the common salt, okay, which we are used as to eat in our food, and that is basically available from the sea. Okay, because what we are doing, we get the salt from the sea by using the evaporation process or the vaporization process, because sea contains the much more amount of salt into it. So we just have to evaporate the water from them. Okay, so if we evaporate or if we vaporize the water from them, then it gives us the basic amount of salt, and that salt comes from the sea will be considered as the common salt, and the scientific name or the chemical name for the NaCl will be sodium chloride. So these are the topics that we already finished. Now we are going to see the next topic, that will be the chlor-alkali process. Okay, but here it is the topic of common salt, we are going to see that. Okay, and then afterwards we are going to see the chlor-alkali process here. Okay, common salt, a raw material for chemicals. Generally we have seen the last topic that three products are came from the sodium chloride, and if we react the sodium chloride with water, it gives us the three byproducts that we have learned in the previous lecture. In last topic we have seen the sodium chloride is react with water, it gives us the three products that will be very much useful in the next topic that we are going to see in today's lecture. Okay, what are that extra byproducts that is come from the process? That will be sodium hydroxide, chlorine and hydrogen gas. If you cannot see this equation, I will send you this equation. This equation is also present in your textbook. So whenever you start to read about that, just open the page of chlor-alkali process in the second chapter. It gives you this equation. Generally sodium chloride and water reacts, and if we do the electrolysis process, what we do, if we do the electrolysis process, then it gives us these three products. Otherwise these three products can't be produced. Just if we just include the sodium chloride into common salt, and if we just put it into the water and if we mix it, then it doesn't give these three products. But what should we have to do? We have to do a electrolysis process. Now we are going to see a basic concept regarding the electrolysis process. Okay, otherwise you cannot understand what will be the electrolysis process. See here I have draw this gives us the basic concept regarding the electrolysis. Now what we have done here, if you remember in 8th standard we have learned about the electrolysis process, in which we have studied this is the process to use to galvanizing or electrolyte the products whenever we have to make the fake golds. Okay, then we are using these types of method. Okay, if you remember that, then we are using this method where we have to put the cathodes into the anodes. Okay, the anode mud goes into the cathode and the purify of cathode will be happen. These types of process we have learned in the electrolysis in the 8th standard. How if we want to rectify the gold, if we want to rectify the silver, then we are using this method. Okay, so for that purpose we are using that. But in today's lecture, this is important, very important, due to first we have to see what are the contents, or what are the things, or what are equipment that we are using it here. First we have used the positive with the rod, or this rod will connect with the positive, that's why it is called as the anode. The rod which we connected with the negative, it will be called as the cathode. And afterwards, what is the process that will start? Whenever I open the switch, this liquid is contained with the sodium chloride. So this is not the pure water. Whatever the liquid I have taken here, it is not the pure form of water. It is the salty water, because if you remember that the pure water cannot pass the electricity. So if we want to pass the electricity, then what we need? We need the salty water. And pure water is not a conductor of the water. Okay, only a mixed water or a salty water is a pure conductor of the electricity. If you remember the Three Idiots movie and you remember the first scene, there is the scene. It explains us the practical example for that. The salty water is a superconductor of the electricity, while pure water is not. That's why I have taken the NaCl containing water here. Okay, because and that is called as the electrolytes. Electrolytes means it passes the electricity through it. Now I open the switch, that will pass the electricity through it, and whatever the anode mode is present here, it goes down to the downside, and this will get the purification of anode. So whatever the metal I have to purify, I have to put it here, and whatever the metals that will be not purified, I have to put here. Okay. So for that the process will begin, and it gives us it rectifies the metal that we have to do. This is the basic concept of electrolysis or electrolyte process. Okay, that is using in the galvanizing process. Okay, or it will also uses in the gold purification method. Okay, now we are going to do this method into the chlor-alkali process. It means what we are going to do, we are going to put the water and salt it here, and afterwards what we gonna do, we are gonna react these three process. Electrolysis process we are gonna do, and that gives us the three byproduct, that will be the sodium hydroxide, it means a base, then it gives us the chlorine, and then it gives us the hydrogen gas. And these three products I will take, and whatever the thing I want to make, I can make it easily. Okay, I hope you can understand the electrolysis process here. Okay, now I am going to erase that. We are going to see the chlor-alkali process. Okay. And if you want to still learn the electrolysis process, in standard 8 I have already uploaded the lecture. You can see it on the YouTube. There is the electrolysis process diagram and also the video regarding that. So you can see it from there. Now going to start. Here this paragraph will be very much important. When electricity is passed through an aqueous solution. Aqueous solution means the liquid which get burned. These types of burning liquids are called as the aqueous solution. Of sodium chloride, it decomposes to form the sodium hydroxide. What happens when the sodium chloride it put it into the aqueous solution, it gets decomposed, and whenever it gets decomposed, it makes the base, and its base is known as the sodium hydroxide. The process is called the chlor-alkali process because it makes the two products, chlorine and alcohol. Chlor means chlorine and alkali means alcohol. So these two products are made from them. Because of the products for the product from the formed chlor and chlorine and alkali from sodium hydroxide, that is why it is called as the chlor-alkali process. I think some type of okay, so some type of technical error is came, so that's why. Now you can see it here. I have taken a container. In container we have taken the brine. Brine means what? Sodium chloride. It is the another name for the sodium chloride, so don't confuse it with the brine. Okay, if you heard the word brine, it does not mean that something new came. Okay, you just have to memorize the sodium chloride for that. Now we're going to see product and the process regarding the chloralkali process. So what is the we have taken the we have taken the common salt water here. We are going to put the salt from here, so it get mixed with the H2O. H2O means this water. Okay, and what is we have done? We have put the two metal rods here for the electrolysis process, and these two rods, whatever the rod I am attached with the positive, it will be noted as the anode, and whatever the rod I have put it with the negative, it will be called as the cathode. Okay, if you can see it here, it is anode and it is cathode, and here whatever the water I have taken, it will be called as the H2O. I have done only a mixing process. I have not started process yet. Still I have not started the process. Okay, now we are going to do the process. What we have to do, we have to switch on and turn on the supply that will decompose the sodium chloride. That is present here. Okay, sodium chloride present in this water. This will get decomposed when I switch on the supply, and this gives the three product. First product, that will be called as the sodium hydroxide, came it from here. Okay, as you can see here, the sodium hydroxide is the product, came it from here. Okay, it is the sodium hydroxide. So first product, when this product came, wherever I start the supply of the H2 and NaCl becomes a decomposition due to the electricity is passed through it. Okay, due to the electricity is passed through the anode and cathode, it will decompose the sodium chloride that is present here, and that mixed with the H2O's OH ion present in it, and chlorine gets release it from them, and OH will gets mixed with the sodium. It gives us the first product, that will be known as the NaOH, and we will take the sodium hydroxide here. Another product that is came from this, and that is very much important, is the chlorine. So what happened to the chlorine? Chlorine will come to the gas and convert it into the gas, and the chlorine product is released from here. You can see it here. So chlorine product is released from here. And third product, the hydrogen gas, is released from here. Now we are going to use this sodium hydroxide, chlorine and hydrogen where it is written here. So we are using the sodium hydroxide into the metal, soaps, detergent, paper making and artificial fiber. These all the products gets sodium hydroxide. Without the sodium hydroxide, I cannot make this product. So if I want to make this products, what should I have to do? I have to get the sodium hydroxide, and where this sodium hydroxide is available, whenever we do the chloralkali process, then and then only I get this product, and this product will be used in this types of thing. Then a chlorine. So if you ever heard whenever you goes to the swimming pool, there the swimming pool has a clean water. So why it is so clean? Because it has a chlorine in it, and that will get that will be the use for the chlorine. And so as you can see it here, chlorine will be used in these types of thing: water treatment, swimming pool, PVC, disinfectants, CFCs, pesticides. Okay. So these are the products we making from the chlorine. And last but not the least, hydrogen. Hydrogens are used for fuels, margarine, ammonia, for fertilizer. These are the uses for hydrogen gas. So if you see it clearly, then lots of products are made from the 3. Okay. If you understand that process, we are going to see now how to make bleaching powder, and afterwards we will see the washing powder and then baking soda. Okay. One time I will repeat that this chlorine will be used in water treatment, swimming pool, PVC and CFCs, it means chlorofluorocarbons, pesticides, and hydroxide will be used in metal, soaps, detergents and paper making machineries. Okay. I am going to erase that and we will start a next topic from this byproduct. Okay. So first we take a chlorine gas and we take the chlorine gas to make the bleaching powder. Okay, we are going to do a making of the bleaching powder, how it is made. So you have already came to know that chlorine is produced during the electrolysis of aqueous sodium chloride, it means brine. This chlorine gas is used for the manufacturing of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked land. If you remember the word in first chapter, I have already told you what is the slaked land. It will define with the CaOH2. We have make the equation of that. Calcium hydroxide, it means CaOH2, and it will be known as the slaked land. So if we are doing a chemical reaction of slaked land with what? With the chlorine that is made up from the chlor-alkali process, we are going to react both of them, and this will give us the CaOCl2. It means the calcium oxychloride, and this will be known as the bleaching powder. It will be called as a calcium oxychloride, and this calcium oxychloride will be known as the bleaching powder, and it also releases the water. Okay, and these are the bleaching powders uses. Once again I will repeat that whenever we react the slaked lime, now what is the equation for slaked lime? It is the calcium hydroxide, CaOH2. If I react this calcium hydroxide with what? With the byproduct from that is came from the chlor-alkali process, that will be the chlorine. Okay, and we are using that product, and if we react both of them, it makes the CaOCl2, calcium oxychloride, and in other words we can say that it is a bleaching powder, and it also releases the hydrogen, it will also releases the water. Now uses for bleaching powder is for bleaching cotton and linen in the textile industry, bleaching wood pulp, paper factories, these are the uses. As an oxidizing agent in many chemical industries, and to make drinking water free from the germs. These are the basic uses, and you already know it. Bleaching powder is used at many places, okay, where we want to wash something or we are going to do something. So these are the mainly its uses. Now to make the baking soda, what should we have to do? Okay. Now, if we want to make a baking soda, the generally used for baking soda, you have already heard the word baking soda, that is used in most of the foods where we have to fill the dough. There are we using the baking soda, and also it will be using in the tasty crispy pakoras. We are sometimes eat in the rainy seasons. For in that mommy has put the baking soda, some of the little bit, that will get us the release it from the acidity, okay, because it has the base in it. And so that is the main use, and that is the main purpose we are using. Sometimes it is added for the faster cooking, okay. If we want to make a cooking faster, then we have to put the baking soda into it. It will just increase the process level in it. The chemical name of compound is sodium hydrogen carbonate. and this sodium hydrogen carbonate is known as the baking soda. Okay, sorry, it is the sodium hydrogen carbonate, and it is produced using the sodium chloride, and the raw material gives us the sodium carbonate. Okay, so first what should we have to do? We have to make this sodium hydrogen carbonate. And how can we make the sodium hydrogen carbonate? First we have to learn this sodium hydrogen carbonate's molecular formula, and that will be NaHCO3, because as we know CO3 means what? Carbonate. So we have to attach carbonate with sodium. Okay, so NaCO3, but it only makes the sodium carbonate, but I have to make sodium hydrogen carbonate. So what should I put? I have to put H in between them, and that makes the sodium hydrogen carbonate. Okay, this is the molecular formula for this. Now if we want to make the sodium hydrogen carbonate, what should we have to do? We have to take NaCl, it means sodium chloride. Here I am writing that it is the common salt. Then we have to process with the water. Then we have to put it with the process in the carbon dioxide gas. Then NH3. Now it is a new word that is came here. NH3 means ammonia. What is signify us? That it gives us the molecular structure of ammonia. So if I do the process of sodium chloride with water, with carbon dioxide gas, and with the ammonia, if I put all these 3 or 4 substance and react with each other, it gives us the 2 byproduct, that will be the ammonium chloride and sodium hydrogen carbonate. And if I react the sodium hydrogen carbonate and if I increase the amount of heat of the sodium hydrogen carbonate, it gives us the sodium carbonate Na2CO3, and that will be the product as known as the baking soda, and it also releases the H2O and CO2. Now sodium hydrogen carbonate is the raw material to make the Na2CO3, and Na2CO3 is known as the baking soda. Now we are going to see the uses of baking soda, and that will be the making baking powder. Okay, mixture of baking soda and sodium hydrogen carbonate, a mild edible acid such as a tartaric acid, these are the uses. Okay, also the second use you can see, this is the ingredient in the antacids. Being an alkaline, it neutralizes the excess of acid. I have already told you that it releases the acidity or the stomach pain in our digestive system or in our stomach. Okay, it is also used in the soda acid fire extinguisher. Okay, this is the main uses of baking soda. Going to see a last topic, that will be the washing soda. Now what is the washing soda? What is washing soda's molecular formula is Na2CO3 and 10 H2O molecules together will be called as the washing soda. So it means it contains the water of amount in it. Sodium carbonate has the water of amount in it present, it will called as the washing soda. So another chemical that can be obtained from the sodium chloride is Na2CO3 10H2O washing soda. You have seen above, the sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also a basic salt because it contains the amount of water and it also contains the sodium in it. That's why we can say that it is basically a sodium carbonate is a basic in a nature. Uses are very easy. It will be used in the glass, soap, paper industry. It is in the manufacturing of the borax, sodium carbonate. We are going to see the borax into the third chapter, where we are going to study about metal and non-metal. There we have to extract the metal, and there is the component or the compound come as the borax. We have to separate them. We are going to see in the third chapter. Sodium carbonate can be used as the cleaning agent for the domestic purpose, and it is also used for removing permanent hardness of the water. After removing the permanent hardness of the water, we can use it to washing our clothes. Okay, otherwise we cannot use the water because it contains the permanent hardness in it. That's why we cannot use it into our drying our clothes or washing our clothes. So for that we have to remove that, and that's why we have to put washing soda into it. Afterwards we are going to mix with the water, and then we are going to put the clothes into it. Okay, so these are the questions we have done today. I am going homework. I am going to give you a homework in today's lecture. Draw and explain Chlor-alkali process. Question 2. How to make baking soda and its uses. Question 3. How to make bleaching powder and its uses. And question 4. How to make washing soda and its uses. See, these are the homework question. Okay, so that's it for today. Thank you very much for joining this lecture. If you had any kind of doubt, you can ask me personally on my WhatsApp, or if you want to call me, you can call. Okay, so thank you very much. Now we will meet in the next lecture. We are going to start our next chapter in the next lecture. So that's it for today. We'll meet in the next lecture. Till then, bye bye everyone, and take care of yourself.